Example number 5. For the given function, find A, the equation of the secant line to the points where x has the given values, and B, the equation of the tangent line when x has the first value. So to find the slope of a secant line, it's f of B minus f of A over B minus A. They gave us A is 1 and B is 4. So we need to find f of 4. So that's going to be 4 squared plus 4. That's 16 plus 4 is 20. And then f of 1 is 1 squared plus 1. So 1 squared plus 1 is 2. So this is going to be 20 minus 2 divided by 4 minus 1. So 18 divided by 3 is 6. So this is the slope of the secant line. Now to write an equation, we can use y equals mx plus b, or y minus y1 is m times x minus x1. And I'll just use y as mx plus b. I do need to have my ordered pair. So here I have when x is 4, y is 20. So I'll use the point 420. I could have also used f of 1, but I'll just go ahead and use f of 4. So y is 20, m is 6, x is 4 plus b. 20 is 24 plus b. Taking 24 from both sides, negative 4 equals b. So the equation of my secant line is y equals 6x minus 4. So here's the formula for the slope of the secant using these specific points. And the equation of the secant is y equals 6x minus 4. Now they want the equation of the tangent. So to find the equation of the tangent, we have to find the instantaneous rate of change, and that's our limiting formula. So the limit as h goes to 0 of f of x plus h minus f of x, all of that has to be divided by h. Our function was x squared plus x, so f of x plus h is going to be x plus h squared plus x plus h, because remember we have to put x plus h here and here. So that's going to give me x squared plus 2xh plus h squared. That's if you FOIL out x plus h times x plus h. And then it's plus x plus h. And so that's just the f of x plus h. And look, there are no like terms. So limit h goes to 0 of x squared plus 2xh plus h squared plus x plus h. And then I have to minus from that the entire original function, which was x squared plus x, and then divide everything by h. Now what should happen is if you take your f of x plus h and your original function, anything in the original function should cancel out. Well, it will if you're careful with your signs here. Limit h goes to 0, x squared plus 2xh plus h squared plus x plus h minus x squared minus x, all of that over h, and you'll see that this x squared and a minus x squared, this x and a minus x, and that leaves us limit as h goes to 0, 2xh plus h squared plus h divided by h. Now, we can't put h equals 0 when there's an h in a denominator. So we've got to divide this h. Notice, when you do this, every time the remaining terms will have an h in them. If they don't, then something's gone wrong. We're going to give that common denominator of h to each term. And that's going to give us the limit. I haven't done h is 0 yet. H goes to 0 of 2x plus h plus 1. So if we let h go to 0, clearly that's a 0. So our formula for our slope of the tangent is 2x plus 1. Now that's the formula for the tangent slope at any x. And they told us that for this problem, the equation of the tangent at the first value of x. So if the formula for the slope is 2x plus 1 and x is 1, then my slope is 2 times 1 plus 1, 2 plus 1 is 3. Now that's the slope of the tangent. And I still have to write the equation. Now remember, we already know when x is 1 what f of 1 is. Remember, we did f of 1 over here and we got 2. So the point is x is 1, y is 2. So y equals mx plus b is 2 equals 3 times 1 plus b. 2 is 3 plus b. If you subtract 3 from both sides, you're going to get negative 1 equals our b value for the tangent line. So that's going to be y equals 3x, because that was our slope of 3. And now our b is a minus 1, so 3x minus 1.